Question 2 in Chapter 12 is asking you to give the IUPAC name for some molecules. So, in this one, you see a characteristic structure that should really stand out. If you ever have a six-membered ring with alternating single and double bonds, or another way that it could be drawn, is this six-membered ring with a circle inside. That's a special molecule with very special behavior, and it's called benzene. Those are benzene rings. And when functional groups are attached to that, as a whole, the benzene ring and the functional group then gets its own common name. So for example, if there's an OH, an alcohol, attached directly to the benzene ring, that altogether is called phenol. That's a common name. There's no way you could have come up with that unless you had been exposed to it and memorized it. But it's something to watch out for. So whenever you see six-membered rings with alternating single and double bonds, step back, ask yourself, do I have benzene or do I have a derivative of benzene, like phenol? And here you have a derivative of benzene, phenol. That is going to be your backbone. So phenol is our backbone. You always want to start numbering derivatives of benzene at the carbon that has the functional group on it. So in this case, that's this carbon right here. That's going to be carbon 1. Now we could either number the ring clockwise or counterclockwise. If we do it clockwise, we'll get a lower number for our branch. So I'm going to do it clockwise. So here, the branch is coming off of carbon 3. On this, and actually let me number this in with a different color. So this is our backbone. We've got 1, 2, 3, 4, 5, 6. Carbon's coming off of, the branch is coming off of carbon number 3. On that branch, we have 2 carbons, and the prefix for 2 carbons is F. And because it's a branch, immediately after the F comes YL. So the name for the branch is 3-ethyl. Take the branch name and put it in front of the backbone name. The backbone name is phenol, and you get 3-ethyl phenol. And so that would be the name of this molecule. Here you have a branch, and so the first thing you want to do is to identify the backbone. Now the backbone is the longest straight chain you can find without picking up your pencil or going backwards. If you have a functional group, the backbone has to include the functional group, even if it's not necessarily the longest carbon chain. So the parent chain, if you have a functional group, is the longest carbon chain you can find that has the functional group on it. The functional group has to be coming off of one of those carbons. So here, we know that the parent chain has to include this carbon right there. So let's see the longest chain we can find with that. Possible chains are 1, 2, 3, 4, or 1, 2, 3. So it looks like the longest chain is 4. That's our backbone. So I'm going to circle this as our backbone. Now I'm going to number. I'll number this. And keep in mind, this is your first carbon. You don't number the oxygen. That functional group is coming off of the carbon chain. You only ever number carbons. And I'm going to number this from right to left. That gives us the lowest numbers for the OH and for the branch. There are 4 carbons, so the prefix for this is going to be bute. There are all single bonds in the carbon chain. So if you have all single bonds, the infix is AN. And we do have a functional group coming off of this molecule. The functional group is OH. You know you have a functional group when you have the symbols of an element written in to the skeletal structure. Excuse me. So the OH is an alcohol, and the suffix for an alcohol is OL. The OH could be coming off of any of those carbons, and so we have to say which one it's coming off of. You can see that it's attached to carbon number 1, so we put that in front. Always between numbers and letters goes a dash. The name for that backbone is 1-butanol. Now we have a branch. The branch is coming off of carbon 2. So I'll put 2 there. There's only 1 carbon in that branch. The prefix for 1 carbon is meth. And because it is a branch, immediately after that prefix comes YL. So the branch name is 2-methyl. So we're going to take that branch name and put it in front of the backbone name. Always between letters and numbers goes a dash. And then full name for that compound will be 2-methyl 1-butanol. So for this one, we have branches. The first thing we need to do is define the parent chain. The parent chain is going to be the longest chain we can find without going back or lifting up our pencil. That includes the functional group. So we're going to start here to give the functional group the lowest number. We only number carbons. We can go 1, 2, 3, 4, 5. You could imagine going 1, 2, 3. You could imagine going 1, 2, 3, 4. It looks like 5 is the longest chain we can find. That includes the functional group. And so I'm going to circle that with the OH. That's our parent chain. So before we number the branches, let's name that parent, or before we name the branches, let's name the parent chain as if there were no branches on it. There are 5 carbons. The prefix for 5 carbons is pent. There are all single bonds in this compound. The infix for all single bonds is AN. And there is a functional group here, this OH. That's the functional group of an alcohol. And the suffix for an alcohol is OL. So we're dealing with a pentanol. We do have to say where the OH comes off of the chain. And you can see that as we numbered it, that is coming off of carbon 1. Always between numbers and letters goes a dash. So the name for the backbone is 1-pentanol. Now that we've named the backbone, let's name the branches. Our first branch is coming off of carbon 2. There is only 1 carbon in that branch. The prefix for 1 carbon is meth, and because it's a branch, immediately after the prefix comes YL. So it's 2-methyl. We have another branch coming off of carbon 3. Always between numbers and letters goes a dash. There's only 1 carbon in this branch. The prefix for 1 carbon, again, is meth. And because it's a branch, immediately after that prefix comes YL. So our 2 branches are 2-methyl and 3-methyl. Because those are the same type of branch, we can smush them together. And what I mean by type of branch, they're both methyl branches. So we can smush them together. Between numbers and numbers goes a comma. Between numbers and letters goes a dash. So we have 2, 3. You have to say how many branches you smush together. Use a prefix for that. We smush 2 together, so the prefix is di. And then say what type of branch. They were methyl branches. So when you squish those together, you get 2,3-dimethyl. That's our branches. Take the branch names, put them in front of the backbone name. Always between numbers and letters goes a dash, and the full name for this compound is 2,3-dimethyl 1-pentanol. In this molecule, there are no branches. There's just the straight chain with the OH coming off of it. And so we don't have to worry about finding a parent chain. We just need to number this in order to find our prefix. Now I could number it left to right or right to left. I'm going to do it right to left to give me a lower number for the carbon that the OH is attached to. If I do it right to left, it's 3. If you were to number this left to right, you'd get a 4. You can see that I have 6 carbons, or we have 6 carbons, and so the prefix is going to be hex. In the molecule, you have all single bonds, and so the infix for all single bonds is AN. Last but not least, we do have a functional group. The functional group is an OH, and that is an alcohol. The suffix for an alcohol is OL. So this is going to be a hexanol. We do have to say where the OH is coming off. You can see that the OH is attached to carbon number 3. So always between numbers and letters goes a dash. So this is 3-hexanol. That'd be the name for for this beautiful compound.